In question 1, we have to solve the equation 8 sine squared theta plus 6 cos theta plus 1 equals to 0. Now, to solve this equation, we have to first bring it in terms of sine or cos. Now, as we have sine squared over here, and we know that the identity is sine squared theta plus cos squared theta equals to 1. So, in place of sine squared, we can now write, so sine squared theta will be equals to 1 minus cos squared theta. So, writing 8 into 1 minus cos squared theta plus 6 cos theta equals to 1 plus 1 equals to 0. Expanding the bracket, we'll get 8 minus 8 cos squared theta plus 6 cos theta plus 1 equals to 0. Now taking it on the right hand side to make the square term positive. So this will become, so taking 8 cos squared on the left hand side, this will become 8 cos squared theta minus 6 cos theta, and 8 plus 1 is 9. So 9 will become a minus 9 equals to 0. Now factorizing this, so to factorize this, we can use our calculators or we can use middle term breaking. So using middle term breaking, this will become 8 cos squared theta minus, so this will become 12 cos theta plus 6 cos theta minus 9 equals to 0. Taking 4 cos common from over here, so we will get 2 cos theta minus 3. And from over here, taking 3 common, this will become 2 cos theta minus 3 equals to 0. Simplifying, we'll get cos theta plus 3 equals to 0. And this will be 2 cos theta minus 3 equals to 0. So cos will be equals to, cos theta will be equals to negative 3 upon 4 and cos theta will be equals to positive 3 upon 2. As cos cannot be greater than 1, so this value will be neglected. And for this part, we'll first find the basic angle, where we'll take cos inverse of 3 upon 4. So cos inverse of 3 upon 4, when we substitute this in the calculator, the basic angle will be 138.59 degrees. Now, as it is a negative sign, so we'll have to make the basic angle. So this will be cos inverse of 3 upon 4. So that is equals to 41.4. So this will be 41.4. So this is for 41.409 degrees. Now making this basic angle in the negative quadrants of cos, and as theta is from 0 to 180, cos is negative in the second and the third quadrant. However, as we just have to, we have the range of theta from 0 to 180, so we'll make 41.409 only in the second quadrant. Once we have made the basic angle, now we can find the value of theta by taking the angle anti-clockwise from the x-axis. So theta will be equals to 180 minus 41.409, and theta will be equals to, so 180 minus 41.409 is 138.59 degrees. As we have to give our answer in angles to one decimal place, so the final answer will be 138.6 degrees. In question 2, the function f is defined by f of x equals to minus 2x square minus 8x minus 13 for x is less than minus 3. In part A, we have to express f of x in the form 2 minus 2x plus a whole squared plus b. So to express 2x square minus 8x minus 13 in that form, we'll first expand it. So this will become minus 2 into x squared plus 2ax plus a squared plus b. Multiplying with minus 2, we'll get minus 2x squared minus 4ax minus 2a squared plus b. And this is equals to minus 2x squared minus 8x minus 13. Now comparing the coefficients on the left and right hand side, for x it is minus 8 on the left hand side and minus 4a on the right hand side. So we'll write minus 4a will be equals to minus 8 equals to minus 8, and a will be equals to positive 2. Now comparing the constant terms, the constant term on the left hand side is minus 13 and on the right hand side it is 2a minus 2a squared plus b. So minus 2a squared plus b will be equals to minus 13. The value of a is 2, so this will become minus 2 into 2 squared plus b equals to minus 13. B will be equals to minus 13. So 2 squared is 4 and 4 times 2 is minus 8. So minus 8 will become a plus over here. So the value of b will be equals to minus 5. Once we have the value of a and b, we can write the final form as f of x will be equals to minus 2 into a is 2. So x plus 2 whole squared, and the value of b is minus 5. So this will be minus 5. In part B, we have to find the range of f. Now the value, the domain of the function f of x is less than equals to minus 3. From the conversion that we did, we know that this minus 2 and minus 5 is the turning point. So to give the range first, we will sketch a graph of the function f of x. So this point will be minus 2. Let's say this point is minus 5, and this negative minus 2 shows that it will have a maximum point. So the curve will be like this, where this point is the maximum point and it has coordinates minus 2 comma minus 5. Now in the question it says that x has to be less than minus 3. So it means the value of x is minus 3 and it has to be less than this value. So we need to find the value of the function at x equals to minus 3, and the function will be less than that particular value. So finding the value of f of minus 3, so this will become minus 2 into minus 3 plus 2 whole squared minus 5. Minus 2 into minus 1 whole squared will become a 1 minus 5. So this will be equals to minus 7. Now, as this negative sign showed that it is a maximum point, and at minus 3, the value of the function, we can see it is minus 7. And the domain of f of x is less than minus 3. So for all the values of the function for x less than minus 3, the function will always be less than minus 7. So we'll write f of x will be less than minus 7. In part C, we have to find an expression for f inverse of x. Now to find the expression for f inverse of a quadratic function, we always make sure that it is converted to the complete square form, which we already did in part A. So this was minus 2 into x plus 2 whole squared minus 5. Finding the inverse, this will become y equals to minus 2 into x plus 2 whole squared minus 5. Now exchanging the values of x and y, so this will become x is equals to minus 2 into y plus 2 whole squared minus 5. Taking 5 on the other side, so this will become x plus 5, and dividing by minus 2, so this will become x plus 5 upon minus 2 equals to y plus 2 whole squared. Now taking the square root, so we can write the negative sign in the numerator. So this can be written as minus x plus 5 upon 2, and taking the square root to get rid of the square root on the left hand side. So this will become square root of negative x plus 5 upon 2 equals to y plus 2. And now taking 2 on the left hand side, so y will be equals to minus 2. And as the square root has a plus minus sign, so this will become plus minus of square root of minus x plus 5 upon 2. So we can write that the function f inverse of x is minus 2 plus minus square root of minus x plus 5 upon 2. However, there is one thing we'll have to be careful about, and that is the domain of the function f of x was x is less than minus 3, which means that the range of this function must always be less than minus 3 as well. So if we take the positive sign minus 2 plus this particular answer, so that answer will not be less than minus 3. So in that case, the only value for f inverse of x will be possible if we take the square root with a negative sign. So the final answer will be minus x plus 5 upon 2, and there will be a negative sign, as we have to make sure that the range of f inverse of x must be equal to the domain of f of x, which is x is less than minus 3. So this must also be, so f inverse of x must also be less than minus 3. In question 3a, we have to find the first three terms in ascending powers of x in the expansion of 1 plus 2x to the power 5. Now the expansion formula for 1 plus b to the power n is 1 plus nc1 b power 1 plus nc2 b power 2. And as we just have to find the first three terms, so we'll expand it up till nc2 b power 2. So for 1 plus 2x to the power 5, n is 5 and b will be 2x. So this will become 1 plus 5c1 2x to the power 5 plus 5c2 2x to the power. So this will become 2x to the power 1, and this will be 2x to the power 2. So 5c1 is 5, so this will become 1 plus 5 into 2x, and this will be 5c2. So 5c2, when we substitute this in the calculator, that is 10, and this will multiply by 4x squared. So this will become 1 plus 10x plus 40x squared. In part B, we have to find the first three terms in ascending powers of x in the expansion of 1 minus 3x to the power 4. So again, applying the same formula, which is 1 plus b to the power n is equals to 1 plus nc1 b power 1 plus nc2 b power 2. So in place of b, now we have minus 3x, and in place of n, it will be 4. So this will become 1 plus 4c1 minus 3x to the power 1 plus 4c2 minus 3x to the power 2. So 4c1 is 4, so this will become 1 minus 4 times 3, which is 12x. And 4c2, when we substitute this in the calculator, that is 6. So 6 will multiply by positive 9x squared, as the negative sign will cancel out. So this will become 1 minus 12x plus 54x squared. In part C, it says, hence find the coefficient of x squared in the expansion of 1 plus 2x power 5 and 1 minus 3x to the power 4. So for 1 plus 2x to the power 5, the expansion was 1 plus 10x plus 40x squared. And for 1 minus 3x to the power 4, the expansion was 1 minus 12x plus 54x squared. Now, to get the coefficient of x squared, we'll have to find terms which, when they multiply, we get an x squared term. So 1 will multiply by 54, so that will be equal to 54x squared. 10x will multiply by minus 12x to give minus 120x squared, and 40 will multiply by 1 to give a plus 40x squared. So 54 minus 120 plus 40, the final answer will be minus 26x squared. So the coefficient of x squared, we'll write the final answer as minus 26 for the coefficient of x squared. In question 4, a large industrial water tank is such that when the depth of the water in the tank is x meters, the volume of the water in the tank is given by V equals to 243 minus 1 upon 3, 9 minus x whole cube. Water is being pumped into the tank at a constant rate of 3.6 meter cube per hour. So as water is being pumped into the tank at a constant rate of 3.6 meter cube per hour, so we can write that dV by dt, or the change of volume with respect to time, is 3.6 meter cube per hour. It says find the rate of increase of the depth, which is x, when the depth is 4 meters, giving your answer in centimeter per minute. Now the relationship between v and x in this case will be dv by dt will be equals to dv by dx multiplied by dx by dt. So first, finding dv by dx, as v is equals to, so v is equals to 243 minus 1 upon 3 into 9 minus x whole cube. Finding dv by dx, so this will become, differentiating 243, that will become a 0. 3 will multiply by minus 1 upon 3, so that will become minus 3 upon 3 into 9 minus x. The power will decrease by 1, and we'll also multiply it with the derivative of 9 minus x, which is minus 1. So minus minus will cancel, 3 and 3 will also cancel. dv by dx will be equals to 9 minus x whole squared. And as x is equals to, the depth of the water is 4 meters, so we'll write x equals to 4. So substituting x equals to 4, 9 minus 4 whole squared will be equals to 25 for the value of dv by dx. Once we have the value of dv by dx, we can write dv by dt, which is 3.6, is equals to 25 into dx by dt. So dividing 3.6 by 25, dx by dt will be equals to 0.144. So, and this is in terms of meters per, this will be, the unit will be meters per hour, as the rate was given in terms of meter cube per hour and the depth was also in meters. It is asking to give the answer in centimeter cube per minute. So as this is 0.144 meters per hour, to convert meters to centimeters, we'll multiply this by 100. And to convert hours to minutes, we have to multiply this by 60. So 0.144 multiplied by 100. And then dividing it by 60, the final answer will be 0.24 centimeters per minute. So the final answer will be dx by dt will be equals to 0.24 centimeters per minute. In question 5, the diagram shows a curve which has a maximum point at 8,12 and a minimum point at 8,0. The curve is a result of applying a combination of two transformations to a circle. The first transformation applied is a translation of 7, minus 3. The second transformation applied is a stretch in the y direction. In part A, we have to state the scale factor of the stretch. Now, looking at the figure, we can see that in the x direction, this is 2 units on both the sides. And as it is a stretch in the y direction, it means that it has only the circle has been stretched only in the y direction. So as it was a circle, it means that if this length is 4 up here, this length would have also been 4 up here. So just looking at the length from this point to this point, this length was 2. So it means for the circle, this length would have also been 2. Now, as we can see now that it has become tripled, or we can say from 6 till 8, it has gone from 6 till 12. So we can say that the stretch factor in this case will be 3, as from 2 units, it has stretched to a total of 6 units in the y direction. So the scale factor will be equals to 3. In part B, it is asking to state the radius of the original circle. Now, as it has been stretched with the scale factor of 3 times in the y direction, and assuming, let's say, if the center was up here, and so the radius would have been from here till up here, so the radius would have been 2. So in this case, the radius of the original circle will be equals to 2. In part C, it says state the coordinates of the center of the circle after the translation has been completed, but before the stretch is applied. Now, if the final y coordinate is at 12 and the stretch factor is 3, so dividing 12 by 3, this point would have been up here before the stretch. And as the radius of the original circle was 2, it means that this would have been the center. So if this was the center, it means that the center coordinates will be 8, 2, as the x value will remain the same. In part D, it says state the coordinates of the center of the original circle. Now, as a translation of 7 and minus 3 had been applied, it means that this center had been taken 7 units to the right, as it is 7, and minus 3, it means it was taken 3 units down. So we'll increase the y coordinate by 3 to find the original circle. So the y coordinate will become, so if this is 8 and 2 up here, so taking it 3 units upwards, that will become a 5. And as it was taken 7 units to the right, so taking it 7 units to the left, so decreasing 8 by 7, that will become, so 8 minus 7 will be 1. So this will be the coordinates of the center of the original circle. In question 6, it is given that alpha is equals to cos inverse of 8 upon 17. Find, without using trigonometric functions on your calculator, the exact value of 1 upon sine alpha and 1 upon tan alpha. Now, to understand this, first we can make a right angle triangle. So let's say we have a right angle triangle and the angle alpha up here is, so if this is the angle alpha, cos inverse or cos theta is given by, so cos alpha would have been given by adjacent over hypotenuse. So adjacent would have been 8 and this would have been 17 up here. So applying Pythagoras theorem first to find this length, which will be the opposite of alpha. So this will be 17 squared is equals to 8 squared plus, let's call it as O squared. So the opposite side would be 17 squared minus 8 squared. 17 squared is 289 minus 64. So that will be 225. And taking square root of 225, so this length will be 15. So the opposite length is 15, which means that sine alpha would be opposite over hypotenuse, which is 15 upon 17, and tan alpha is opposite over adjacent. So that will be 15 upon 8. Now, as it is 1 upon sine alpha plus 1 upon tan alpha, so we can take the reciprocal of this function and write it as 17 upon 15 plus 8 upon 15 to find the value of, so this will become plus 8 upon 15. 17 plus 8 is 25, so 25 upon 15, and simplifying it, we can write the final answer will be equals to 5 upon 3. Question 7, the curve y equals to f of x is such that f dash of x is equals to minus 3 upon x plus 2 to the power 4. The tangent at a point on the curve where x equals to a has a gradient minus 16 upon 27. We have to find the possible values of a. Now, this f dash function basically represents the gradient or the dy dx. So we can write minus 3 upon the x value can be taken as a. So a plus 2 to the power 4 is equals to the gradient, which is minus 16 upon 27. The negative signs will cancel out. Cross multiplying, we'll get 27 into 3 upon 16, and that will be equals to a plus 2 to the power 4. 27 into 3 is 81, so this will become 81 upon 16 is equals to a plus 2 to the power 4. Now taking this fourth root on both the sides to get rid of power 4. So find the fourth root of 81 will be 3, and for 16 it will be 2, and it can be a plus minus sign as it is asking for the possible values of a. So first taking a plus 2 is equals to 3 upon 2, and taking a plus 2 is equals to minus 3 upon 2. So 3 upon 2 minus 2 will become, so 1.5 minus 2 will become minus 1 upon 2, and minus 1.5 minus 2 will become minus 3.5 or minus 7 upon 2. So the two values of a will be a equals to minus 7 upon 2, or a will be equals to minus 1 upon 2. In part B, it says, given that find f of x, given that the curve passes through the point minus 1 comma 5. Now we already have the expression for the derivative, which is minus 3 upon x plus 2 to the power 4. So this is minus 3 upon x plus 2 to the power 4. We will have to integrate the function to find the expression for f of x. So this will become minus 3 into x plus 2 to the power minus 4. Integrating both the sides, this will become f dash of x is equals to, so increasing the power of minus 4 by 1, that will become a minus 3. Dividing it by minus 3, and we'll also have to multiply with the derivative of x plus 2, but that will remain a 1, and we'll add a constant. So minus and 3 and 3 will cancel, so we can say f of x will be equals to 1 upon x plus 2 whole cube plus c. To find the value of c, we'll substitute the point given, which is minus 1 comma 5. So f of x will be equals to 5, and x will be equals to minus 1, which will be minus 1 plus 2 whole cube plus c. So 5 will be equals to 1 upon 1 cube, which will be a 1. So 5 will be equals to 1 plus c, and c will be equals to 4. We can finally write the answer for f of x as 1 upon x plus 2 whole cube plus 4. In question 8, the diagram shows two identical circles intersecting at points A and B with centers at P and Q. The radius of each circle is r, and the distance PQ is 5 upon 3r. In part A, we have to find the perimeter of the shaded region. Now, to find the perimeter, it means that we will have to find the arc lengths of AB from the circle with the center P, and the arc length of AB again with the center from Q. We can see that both of these arc lengths will be exactly of the same size, as both the circles with center P and Q have the same radius. Now, to find the arc length, we'll first have to find one of the angles. So if I make a line from A to Q, this length will also be R. To find this angle, we can apply the cosine rule, as we already have these two lengths as R and R, and the length of PQ is 5 upon 3R. Or we can make a straight line from A to the line PQ. This will make a right angle up here, and the length, let's call this point as X. The length PX will be equals to half of 5 upon 3R. So we can say that the length of PX will be 5 upon 6R. Now to find this, the angle APQ, we can use opposite or hypotenuse sine theta to find the angle. So for angle APQ, this length PX is 5 upon 6R. So as it is adjacent to this angle, let's call this angle theta. As it is adjacent to the angle theta, we can use cos over here. So this angle will be equals to, so we can write cos theta will be equals to the length of px, which is 5 upon 6r, upon the hypotenuse, which is r. So r and r will cancel out, taking cos inverse of 5 divided by 6. So this length will be 0.58568. So the angle theta is 0.58568. We can round it off to make it 0.5857. Now, to find the perimeter, we already have this angle over here. The length from P till this point will be R as well. So this, let's call this point as, this point is C. So to find the arc length C, we can use a formula S equals to R theta. So finding the arc length AC, we can use the formula S is equals to R theta. Now the radius is R and theta will be 0.5857. Now, once we have the arc length AC, we can, as all of these arcs will be of the equal length, so we can multiply it by 4 to get the total perimeter of the shaded region. So the total perimeter will be equals to 0.5857 R multiplied by 4. So multiplying 0.5857 by 4, the answer will be 2.3427 R. Rounding it off to 3 significant figures, the final answer will be 2.34 R for the perimeter of the shaded region. As we have to give our answer in terms of R, so we'll leave it as 2.34 R. In part B, we have to find the area of the shaded region in terms of R. Now, to find the area of the shaded region, what we can do is, we can just take the sector APC. We can find the area of the sector, subtract the area of the triangle APX. So we'll get 1/4 of the shaded region. Then we can multiply our answer by 4. So first, finding the area of the sector APC. So area of sector APC will be equals to 1 upon 2 R squared theta. So R will remain as it is, and we already have the value of theta, which was 0.5857. So 0.5857. So 0.5857 divided by 2 will be, so dividing 0.5857 by 2, the answer will be 0.29285. So this will be 0.29285 R squared. And now finding the area of the triangle. So the triangle is the triangle APX. We have the two lengths between the two lengths R and 5 upon 6R, and the angle theta, which is 0.5857. So for finding the triangle area of the triangle APX, we'll use the formula half AB sine of C. Now, as one of the lengths is R and the other length is 5 upon 6R, and the angle will be 0.5857. So substituting this in the calculator, we will get sine of 0.5857, which is 0.5527. Multiplying it by 5 and dividing it by 12, we'll get 2.303 R squared. Now for finding 1/4 of the shaded region, so subtracting these two areas, we'll get 1/4 of the shaded region. So that will be equals to 0.29285 R squared minus 0.2303 R squared. Subtracting this from 0.29285, the answer will be 0.0625252 R squared. And then finally, the shaded region will be this answer multiplied by 4. So the final answer for the shaded region will be, so the area of shaded region will be equals to 0.06252 R squared multiplied by 4, which will be equals to, so multiplying our answer by 4, we'll get 0.2500. 2500 r squared. So we can leave our final answer as 0 to 3 significant figures. It will be 0.250 r squared for the area of the shaded region in terms of r squared. In question 9, the first term of a geometric progression is 216 and the fourth term is 64. In part A, we have to find the sum to infinity of the progression. To find the sum to infinity, we use the formula a upon 1 minus r. So we need the values of a and the value of r, which is the common ratio. Now, to find the value of a and r, in the question, the first term is 216. This means that a will be equals to 216, and the fourth term is 64. So the nth term of a geometric progression is given by a r to the power n minus 1. As we already have the fourth term, which is 64, so we can write this as 64 equals to a, which is 216, into r to the power 4 minus 1. So 4 minus 1 will become 3. So r cube will be equals to 64 divided by 216. Taking the cube root on both the sides, so the cube root will cancel with the cube on r. So r will be equals to cube root of 64 upon 216, which is equals to 2 upon 3. Once we have the value of r, we already had the value of a, we can find the sum to infinity. So the sum to infinity will be equals to 216 divided by 1 minus 2 upon 3. Substituting this value in the calculator, the sum to infinity will be equals to 648. In part B, it says that the second term of a geometric progression is equal to the second term of an arithmetic progression. Now, geometric progression is given by a r to the power n minus 1, and an arithmetic progression's nth term is given by a plus n minus 1 into d. It says that the second term of a geometric progression is equal to the second term of an arithmetic progression. It means it will be a r to the power 2 minus 1, and that will be equals to a plus 2 minus 1, which is 1 into d. So that will become a plus d. It also says that the third term of a geometric progression is equal to the fifth term of the same arithmetic progression, which means this will be a r to the power 3 minus 1 will be equals to a plus. So as it is a fifth term, so we'll write 5 minus 1 into d. So that will become a plus 4d. Now, from the previous part, we already have the value of a, which was 216, and the value of r, which was 2 upon 3. So we can write this as, for the first equation, this will be 216 into r, which is 2 upon 3 to the power 2 minus 1 is equals to a plus d. 216 into 2 upon 3 will be equal to 144. So we can write that the first equation will be a plus d equals to 144. Substituting a and r into the second equation, which was ar squared equals to a plus 4d. So a was 216 into 2 upon 3 whole squared is equals to a plus d. 216 multiplied by 2 upon 3 whole squared will be equals to 96. So the second equation will simplify down to become a plus 4d equals to 96. Solving the two equations simultaneously, we'll be able to find the value of a and d. So the first equation is a plus d is equals to 144. A plus 4d is equals to 96. Now we can directly substitute this value in the calculator to solve the simultaneous equation, and we'll be able to get the values of a and d, or we can use elimination method. So if we use the elimination method, we can add a negative sign to the second equation. A and a will cancel. D minus 4d will be minus 3d. 144 minus 96 is 48. So d will be equals to 48 divided by minus 3, which is minus 16. Substituting the value of d into either one of the two equations, we'll be able to find the value of a. So using the first equation, we'll write it as a plus, so d is minus 16, so that will become minus 16 is equals to 144. So a will be equals to 144 plus 16, which will be equals to 160. Once we have the values of a and d, we can now find the sum of the first 21 terms of the arithmetic progression. So the sum of n terms of an arithmetic progression is given by n upon 2 into 2a plus n minus 1 into d. N is 21, so this will be 21 upon 2 into 2, as a is 260, so that will be 2 into 160 plus n minus 1, so that will be 21 minus 1 times minus 16. So this will be 21 upon 2 into 200 into 160, that is 320 plus, so 20 times minus 16 will be equals to minus 320. So this will become 320 minus 320. Simplifying using our calculator, so 320 minus 320 will be equals to 0. So 0 multiplied by 21 upon 2 will be equals to 0. So the sum of 21 terms will be equals to 0. In question 10, the diagram shows the circle x squared plus y squared equals to 2 and the straight line y equals to 2x minus 1 intersecting at the points A and B. The point D on the x-axis is such that AD is perpendicular to the x-axis. It means that the x-coordinate of A and D will be the same. In part A, we have to find the coordinates of A. Now, as the line and the curve are intersecting at the points A and B, we can solve the equation simultaneously to find the points of intersection. So the equation of the circle is x squared plus y squared equals to 2. The equation of the line is y equals to 2x minus 1. Substituting y equals to 2x minus 1 in the equation of the circle. So this will be y squared plus 2x minus 1 whole squared equals to 2. Expanding 2x minus 1 whole squared, so that will become 4x squared minus 4x plus 1. And bringing 2 on the left hand side, so this will be minus 2 equals to 0. 4x squared plus x squared is 5x squared minus 4x and plus 1 minus 2 is a minus 1 equals to 0. Now factorizing the quadratic equation, we'll get 5x squared minus 5x plus x minus 1 equals to 0. Taking 5x common, so this will become x minus 1, and taking 1 common, this will become x minus 1 equals to 0. Simplifying, taking x minus 1 common, we'll get x minus 1 and 5x plus 1 equals to 0. So the two values of x will be x equals to 1 and x equals to minus 1 upon 5. Now, as we are trying to find the coordinates of A, and A is on the positive side of the x-axis, it means the x coordinate for A will be 1. To find the y coordinate, we'll substitute x equals to 1 into either the equation of the line or the equation of the curve. So taking the equation of the line, which is y equals to 2x minus 1, this will be y is equals to 2 into 1 minus 1. So the y coordinate will be 1. Finally, the coordinates of A will be 1, 1. In part B, we have to find the volume of revolution when the shaded region is rotated through 360 degrees about the x-axis. We have to give our answer in the form pi upon A into b square root of c minus d. So to find the volume of a region when it is rotated through 360 degrees about the x-axis, we use the formula pi into the integral of y squared with the limits b and a. So in this case, first we have to find the limits. Now we can see that the circle is intersecting the x-axis, and this the length from 0 till this point will be the radius of the circle. The equation of the circle is x squared plus y squared equals to 2. So first, using this equation, we'll try and find the radius of the circle. As the equation is x squared plus y squared equals to 2, and we know that the general form of a circle, equation of a circle, is given by x minus a whole squared plus y minus b whole squared is equals to r squared. A and B are 0 as the center is origin. So we can say that r squared will be equals to 2 and r will be equals to the square root of 2. So the upper limit in this case will be the square root of 2, and the lower limit will have the x coordinate of d, which is equals to 1. So the limits are square root of 2 and 1. Now in place of y squared, as the equation of the circle is x squared plus y squared equals to 2. So y squared will be equals to 2 minus x squared. Substituting 2 minus x squared in place of y squared. Now we'll integrate 2 minus x squared. So integrating 2, that becomes 2x. Integrating x squared, so increase the power of x by 1. So that will become x cubed upon 3. And the limits will be square root of 2 and 1. And we'll add pi to the final answer. Now substituting square root of 2 in place of x, so we'll get, so substituting x equals to square root of 2, that will become 2 square root of 2 minus square root of 2 whole cube upon 3. And then substituting x equals to 1, which is the lower limit. So this will become 2 into 1 minus 1 cube upon 3, which will be equals to 1 upon 3. Now simplifying this, we'll get 2 into square root of 2 minus, so 2 square root of 2 can be written as 2 to the power 3 upon 2. So this will become minus 2 to the power 3 upon 2 upon 3 minus, and 2 minus 1 upon 3 is will become 3 times 2, which is 6. 6 minus 1 is 5. So this will be 5 upon 3. Taking the LCM, we'll get, as the denominator over here is 1. So this will become 3 times 2, which is 6 square root of 2 minus 2 times 2 to the power 3 upon 2. So we can write it as 2 multiplied by square root of 2, as 2 to the power 1 plus 1 upon 2 becomes 3 upon 2. So we can write 2 to the power 3 upon 2 as 2 square root of 2. This will be minus 5 upon 3. So 6 square root of 2 minus 2 square root of 2 is 4 square root of 2 minus 5 upon 3. And we'll add pi to the final answer. Now, as we had to give our final answer in the form pi upon a bracket b square root of c minus d, so we can write 1 upon 3 outside the bracket. So this will become pi upon 3 bracket 4 square root of 2 minus 5, which will be the volume of the shaded region for the limits square root of 2 and 1. In part C, we have to find an exact expression for the perimeter of the shaded region. Now, if you look at the shaded region, it consists of 3 parts. One of them is basically an arc length of the circle with center O. The other length is a straight line from A till D, and a third length which is from D till the point where this circle is intersecting the x-axis. Now, we already know that this intersection point is square root of 2, and the x-coordinate of D is 1. So this length will be square root of 2 minus 1. The y-coordinate of A was 1, so the length from D till A will also be 1. And now to find the arc length, we can first try and find the angle of this sector, and then we can apply the formula S equals to r theta. Now the radius of the circle is square root of 2, and from A till D, the length is 1. So to find this angle, we can use adjacent over hypotenuse, which is, so this will be cos alpha will be equals to 1 upon square root of 2. Cos inverse of 1 upon 2 will become pi upon 4. So the angle is pi upon 4, applying the formula for arc length, which is S equals to r theta. So S is equals to r theta. Radius is square root of 2 multiplied by theta, which is pi upon 4. Once we have the arc length, we can add the remaining 2 lengths to find the perimeter of the shaded region. So the perimeter will be the arc length, which will become pi root 2 upon 4 plus, so one of the lengths was root 2 minus 1, and the other length was minus 1, was 1 plus 1. Simplifying this, we'll get pi root 2 upon 4 plus root 2, and minus 1 plus 1 will cancel out. So the final answer for the perimeter will be pi root 2 upon 4 plus root 2. In question 11, the coordinates of A, B, and C are given as A 5, minus 2, B 10, 3, and C 2P, P, where P is a constant. In part A, it says that given that AC and BC are equal in length, find the value of the fraction P. Now, we'll apply the distance formula to both AC and BC. We know that the distance formula is square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Now, finding the length of AC, we can take x2 as 2p, so that will become square root of 2p minus the x-coordinate of A, which is 5, so 2p minus 5 whole squared plus the y-coordinate of C is p, so this will become p minus 2 whole squared, and that is equal to BC. So applying the same formula to BC, that will become 2p minus the x-coordinate of B, which is 10 whole squared, plus p minus the y-coordinate of B, which is 3 whole squared. Expanding, now we can cut off the square roots by taking the square on both the sides. So the square roots will cancel out. Now expanding 2p minus 5, we'll get 4p squared minus, so 2ab will become 2 times 2, which is 4. 4 times 5 will be 20. So this will become 20p plus 5 squared is 25 plus, so this will become p plus 2 whole squared. Expanding p plus 2 whole squared, we'll get p squared plus 4p plus 4 equals to, now expanding 2p minus 10 whole squared, that will become 4p squared minus 10 times 2, which is 20. 20 times 2 will become 40. So that will be minus 40p plus 100. And expanding p minus 3 whole squared, that will become p squared minus 6p plus 9. First simplifying both the sides, so 4p squared plus p squared will become 5p squared, minus 20p plus 4p will become minus 16p, and 25 plus 4 is 29. And on the right hand side, we have 4p squared plus p squared, which is 5p squared, minus 40p minus 6p will become minus 46p, and 100 plus 9 will become 109. Now bringing the right hand side on the left hand side, so this will be 5p squared, and this will become a minus 5p squared. This is minus 16p, and minus 46 will become a plus 46p. And as we are trying to find the value of p, so we can take 29 on the right hand side. So this will become 109 minus 29. 5p squared and 5p squared will cancel. Minus 16 plus 46 is 30p. And 109 minus 29 will become 80. So p will be equals to 80 upon 3. And we can simplify 80 upon 30. And we can finally write the answer as 8 upon 3. In part B, it is given instead that AC is perpendicular to BC and that P is an integer. We have to find the value of P. Now, if two lines are perpendicular, if you multiply the gradients, that is equals to minus 1. So we can multiply the gradient of AC and the gradient of BC, and that will be equals to minus 1. So we know that the coordinates of A are given. The coordinates of A are 5, minus 2. The coordinates of B are given as 10, 3. And the coordinates of C are 2p, p. First, finding the gradient of AC. So gradient of AC will be equals to y2 minus y1. So that will become p minus minus 2 upon x2 minus x1. So that will be 2p minus 5. The gradient of BC will be p minus 3, which is y2 minus y1 upon 2p minus 10. Now, as the lines are perpendicular to each other, we'll multiply the gradients and put them equals to 1. So this will be p plus 2 upon 2p minus 5, multiplying it by p minus 3 upon 2p minus 10, and writing it equals to minus 1. So multiplying p plus 2 into p plus 3 will get. So we can first take the denominator on the right hand side and multiply it by minus 1. So p plus 2 into p minus 3 will be equals to 2p minus 5 into 2p minus 10. And this will multiply by minus 1. So expanding the bracket, we'll get p squared minus 3p plus 2p minus 6. And expanding the bracket over here, we'll get 4p squared. So 2p into minus 10 will become minus 20p. Minus 5 into minus 5 into 2p will be minus 10p, and minus 5 into minus 10 will become a plus 50. Simplifying both the sides, we'll get p squared minus p minus 6, and this will become minus bracket. So this will be 4p squared minus 30p plus 50. And now in the next step, we can multiply the whole bracket by the negative sign. So this will become p squared minus p minus 6 is equals to negative 4p squared plus 30p minus 50. Now taking the terms on the right hand side to the left hand side, we'll get p squared plus 4p squared minus p, and plus 30 will become a minus 30p, and this is minus 6, and minus 50 will become a plus 50 equals to 0. Simplifying, we'll get 5p squared minus 31p. Minus 6 plus 50 is plus 44 equals to 0. Now we can factorize this using our calculators or using middle term breaking. We'll get 5p squared minus 20p minus 11p plus 44 equals to 0. Taking 5p common, we'll get 5p into p minus 4. Taking 11 common, this will become p minus 4 equals to 0. Simplifying, this will be 5p minus 11 into p minus 4 equals to 0. So the value of p will be 4, and the second value will be p equals to 11 upon 5. As it said in the question that p is an integer, it means that the only value of p that we'll use for the final answer will be p equals to positive 4. In part 2, we have to find the equation of the circle which passes through A, B, and C, giving our answer in the form x squared plus y squared plus ax plus by plus c equals to 0, where A, B, and C are constants. Now, from the previous part, we already have the value of P, which was 4. So the coordinates of C are, which were 2P comma P. Now we can write it as 8 comma 4. We already have the coordinates of A, which were 5 comma minus 2, and the coordinates of B, which were 10 comma 3. Now, from the previous part, we know that the lines are perpendicular to each other. So if we have a circle, two lines can only be perpendicular to each other if one of the lines is passing through the center and the other point lies at the diameter. So the angle formed at the diameter will be a right angle. And as it said that in the previous part, it said AC is perpendicular to BC, which means, so this point was A, this point will be, so as these two lines are perpendicular, so this will be C, and AC and BC were perpendicular to each other. This shows that AB will be a diameter of the circle and the center part or the midpoint of AB will be the center of the circle. So the general form for the equation of a circle is x minus a whole squared plus y minus b whole squared equals to r squared. We can first find the coordinates of A and B, which are the coordinates of the center of the circle, by finding the midpoint of AB. So the midpoint of AB will be equals to x1 plus x2 upon 2. So that will become 5 plus 8 upon 2, comma. So y1 is minus 2 plus 3. So that will become minus 2 plus 3 upon 2. 5 plus 8 is 13. So that will become 13 upon 2. And that was the x coordinate of B was 10. So that will be 5 plus 10. So we'll get 15 upon 2, comma 1 upon 2, which will be the coordinates of the center of the circle. Now to find the radius, we can find the distance AB and put it divided by 2 to find the radius. So the distance of AB will be square root of x2 minus x1 whole squared. So this will become 10 minus 5 whole squared plus 3 minus minus 2 whole squared, which will become 3 minus minus 2 whole squared, as minus minus makes it a plus. So we'll get 10 minus 5 squared, which is 25, and 3 plus 2 whole squared, so that will become 5 squared. So this will become square root of 25 plus 25. So the length of AB is equals to square root of 50, which means that the radius will be square root of 50 upon 2. Now substituting these values of the center and the radius in the general form of the equation of a circle, we'll get x minus, so 15 upon 2 whole squared plus y minus 1 upon 2 whole squared is equals to r squared. So that will become square root of 50 upon 2 whole squared. Expanding x minus 15 upon 2 whole squared, so that will become x squared minus 2 into x into 15 upon 2 plus 15 squared, plus expanding y minus 1 upon 2 whole squared, so that will become y squared minus 2 into y into 1 upon 2 plus 1 upon 2 whole squared, which will become 1 upon 4. So we can write 1 upon 4 in place of, and this is a 15 upon 2 whole square. So this will become 1 upon 4 is equals to square root of 50 will become square root of 50 whole squared will be 50, and 2 squared will become a 4. Now simplifying this, 2 and 2 will cancel out. So we'll get x squared minus 15x plus 225, 15 squared, which is 225 upon 4, plus y squared minus, so this 2 and this 2 will also cancel out. We'll get y squared minus y plus 1 upon 4 is equals to 50 upon 4. Taking 225 upon 4 and 1 upon 4 on the right hand side, so we'll get x squared plus y squared. This is a minus 15x, so this will become minus 15x minus y, and we'll get on the right hand side, this will be 50 upon 4 minus 225 upon 4 minus 1 upon 4. Simplifying, we'll get x squared plus y squared minus 15x minus y is equals to 50 minus 225 minus 1 divided by 4. So 50 minus 225 minus 1 is equals to 176. 176 divided by 4 is minus 44. This will be written as x squared plus y squared minus 15x minus y is equals to negative 44. Now, as we had to give our answer in the form x squared plus y squared plus ax plus by plus c equals to 0. So we'll bring the negative 44 on the left hand side and write the final answer as x squared plus y squared minus 15x minus y plus 44 equals to 0.